Hello students, welcome back to my channel. I have decided to start the playlist of past year previous questions which had come in CSIR net from June 2011 to 2022 and discuss its solutions. First I will start with linear algebra and group theory and then rest of the subjects. So in this lecture I will discuss the questions of group theory.
We will discuss some questions related to group theory past year, which had come in past year CSIR net paper, June 2011, part B. Question 1. Consider a group G and let its center be Z. ZG, that is all the those elements of group G which commute with all the elements of a group. And for any fixed n belonging to natural numbers, define Jn in such a way that it belongs to center of G n times direct sum with the condition G1 into G2 up to Gn is equal to identity as a subset of a direct product group G direct sum G and G till the n times. Jn is what? Not necessarily a subgroup, but not a normal subgroup, and isomorphic to direct product n minus 1 times. So let's see what it is. First, let's check is it a group or not, subgroup or not. All right. So now we will check answer. For a subgroup, what we will check that AB inverse belongs to H. This is the condition where A and B belongs to H. So consider G1, Gn belonging to Zn and H1, Hn also belonging to Zn. Let it be A and let it be B. So now we have to show that if AB inverse belongs to H or not. For that, what is AB inverse? That is G1, H1 inverse, comma G2, H2 inverse up to Gn, Hn inverse. Now, if G1 and H1 belongs to center of G by the definition of Zn, then since center of G is a normal subgroup of G, it would imply that G1 H1 inverse belongs to center of G. Hence, this element belongs to center of G up to n times. Now we have to check whether it belongs to Jn or not. Its condition is that product of all these individual components should be identity. Now, since G1 up to Gn is equal to identity and H1 up to Hn is identity, then G1 H1 inverse, G2 H2 inverse in product multiplication basically, Gn Hn inverse is what? Now since these all HIs and GIs are the elements of center of a group, so they commute with all the elements of the group. Hence H1 inverse also commutes because center of G is a group, subgroup. So we can uh, commute them and put it in this order G1, G2 up to Gn, H1 inverse, Hn inverse. Alright, now if we inverse this equation, that is this, so what we will get? H1 dot 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 Hn inverse, whole inverse. You know the formula that if we do AB inverse, it is by reversal of B inverse, A inverse. So in the same fashion, it would be Hn inverse, Hn minus inverse up to H1 inverse, E inverse, identity inverse is identity. So we have to again reorder it since they are the elements of center of G and they commute. Alright. So by reordering, we get G1, G2 up to Gn, which is identity. I haven't written. but I could have written Hn inverse up to H1 inverse, which is equal to identity times identity, which is identity. Hence, our AB inverse elements belongs to Jn, which implies Jn forms a subgroup of G cross G n times. Now we have to check whether it is a normal subgroup or not. It would be, because we know that center of G is a normal subgroup. Now let's just check what is its condition. If A belongs to Zn and G belongs to G cross up to G, that is G is equal to G1, Gn, and let it here be B, because B we have taken H1, Hn. Now we have to show that if G, B, G inverse belongs to Zn or not. Okay. Now G, B, G inverse would be G1, H1, G1 inverse, G2, H2, G2 inverse up to Gn, Hn, Gn inverse. Alright. Now, as we know that center of a group is a normal subgroup of G, so this will belong to center of G, because H1, H2 and up to Hn belongs to center of G. Hence it belongs to center of G n times. Now, we just need to see that whether it belongs to Zn or not. For that we will check G1, H1, G1 inverse, G2, H2, G2 inverse up to Gn, Hn, Gn inverse belongs to Z, should be identity. Now we know that H1 belongs to center of G. So basically H1 and G will commute, H2 and G2 will commute, Hn and Gn will commute, which will imply H1, G1, G1 inverse, H2, G2, G2 inverse up to Gn, Gn inverse, here will be Hn, which in turn is equal to H1 identity, H2 identity up to Hn identity, which is equal to H1, H2, Hn, which in turn is identity. Hence, this element are belongs to Zn and it is a normal subgroup of G cross G n times. Thank you.